All right, so this is problem number 68 out of section 3.2.1. And in this particular case, we're given the negative natural log of e, and we're asked to basically use the properties of natural logarithms, or of any logarithms, to figure out what this is equal to. Now, you can actually, this is a special case, so you could even just go back and take a look at it, but I want to kind of walk through the full steps, and then I'll kind of show you the shortcut. Now, with this particular problem, if you're not comfortable yet with the natural log, we can rewrite this as negative log base e, okay, of e, and we know that that is equal to, now I've been referring back to my definitions, and all I'm doing here is rewriting the definition, filling in everything that I know, and then I don't know what k is, so I'm just going to leave it as k. Now we have one unknown, and that happens to be what we're looking for. We're looking for what k equals. Now, the issue that I have is if I compare this to my definition, it's not exactly the same, and we need it to be exactly the same. Now I want you for a moment to think about, and you can pause this, what we would do to make it the same. There's one characteristic about this piece that's not right, and hopefully you got it. The characteristic is this negative, so I need to get rid of that negative. I'm going to go ahead and divide by -1 and divide by -1. Okay. Now that'll cancel this, so we end up with log base e of e is equal to, now really this is what I'm looking for. I have k over -1, or just negative k. So now I've come up with an equivalent relationship, and if I find out what k equals, then I'll be in good shape and I will know what my logarithm here is equal to. And if you think about it, this makes sense. If the negative log base e of e is equal to k, then log base e of e is going to be equal to negative k. Okay, they're still opposites. Now, based off this, I need to identify, oh, well, this is my base. I have my exponent over here, and I have my argument right up here. So, based off of that, I can fill in and I can write this in exponential form and see if perhaps that will shed some light on what I need to be doing. So I have a base of e. Now e is going to be raised to the negative k. Okay. And that must equal the argument, which in this case is e. Now, we've seen before that when we have the same base, the only way for the two equations to be equal is if they also have the same exponent. Now, this is e to the first power, so these will be equal when negative k is equal to 1, or when k is equal to negative 1. Now, if I go ahead and I plug this back into the original equation that I had, what I find is that we have negative natural log of e is equal to k, which we found to be negative 1. Now, there is also a simpler way to do this if you memorize the definition, and you would notice basically, okay, that the log of e, well, e to the k, so if we just looked at this piece right here, we would have e as our base, to the k must be equal to e to the first. Well, we know that k equals 1. This is actually a property of all logs, all natural logs. The natural log of e, okay, so the natural log of its base is equal to 1. So if we know that, then we can replace negative log e, okay? Well, this is simply equal to 1. We keep the negative out in front, therefore it must equal negative 1. Okay. This obviously is much shorter, but the original explanation explains how you could do this even if it wasn't a special case, and also illustrates how we learn this property in the first place.